Hi ho, so here we go. Here's the question. The heights of adult males in a country are normally distributed with a mean of 180 centimetres and a standard deviation of sigma centimetres. 17% of these men are shorter than 168 centimetres. 80% of them have heights between 192 minus 8 centimetres and 192 centimetres fine h. And what I've got there on the right hand side there is what you'll need. So you will need a GDC to solve this, and the formula that's on your formula sheet, which is Z equals X minus mu over sigma. So I'll explain why we need that as we go along. But let's try and make sense of the question first to see where to go, really. So this is just thinking out loud, really. First of all, I guess I'd highlight the critical parts. We've got a mean of 180 centimetres. Standard deviation of sigma centimetres basically simply means that the standard deviation is not known. This doesn't help us. We're told that 17% is 168 centimetres, or shorter than 168 centimetres. So that gives us something. And then the other fact we've got, which I guess is critical for the start of the problem in a way of understanding it, is that 80% of them have heights between 192 minus h and 192, and we have to find h. I guess the other critical thing as well, which I didn't point out, is that we are told they are normally distributed. That's important as well. To spell that out, what I'm trying to say is that if I do draw my normal distribution, like so, which I never draw quite accurately, but that's the middle there, we're told that there's a mean of 180 centimetres, so that's 180 centimetres there in the middle. And we're told that 80% of them have heights between 192 minus 8 centimetres and 192. Well, what does that mean? Well, it kind of means that if I take 192, which is somewhere, I don't know how accurate I'm making this dotted line here, but if that's 192 centimetres there, and then there's 192 minus h. Now, it doesn't have to be symmetrical, but I do know it needs to be something, so I'm going to deliberately make it not symmetrical. No, that feels symmetrical. It wasn't meant to be. That's 192 minus h, like so. So what it's saying is that 80% of them have heights between 192 minus h and 192. Now, I'm only guessing that the 192 minus h is, I'll just write that in there, is before 180, only because it would be really strangely skewed if 80% was above 180. So I'm pretty confident it will be somewhere below 180. So all I'm doing now is I'm trying to make sense of the problem. So if I can work out what that h is, I'm good to go. Now, one thing I might remind you then is that a bit of a standard calculation would be if I'll just do a quick short one here. Oh, darn it. That's terrible as well. Sorry, I'll do the curve first. Which is what I should always do. If I do 192 as being here, then all of this is the probability of x less than 192. So if I want to work out what this bit is, this point, then I just need to work out what all of this is and subtract what 80% is, and that'll give me what this is, and therefore I'll be able to work out that. That's the general approach here. You'll see that pan out in a second. Okay, so I've got a bit of an approach here. What else do I know? All of this relies on me knowing exactly what sigma is, and I don't know what sigma is, because if I know what sigma is, then when I go into my calculator and I go to menu, probability, and I go to distributions, and I use normal CDF, like so, cumulative distributed frequency, I can use a lower bound of that. Basically means a lower bound of zero, of negative infinity, I can use an upper bound of 192. I know what my average is, it's 180, but I don't know what sigma is. If I know what sigma is, then this will give me all of that. So basically all of this plus that little tail there as well. It'll give me all of that. But in order to make sense of that, I need to know what sigma is. I don't know what sigma is, so this formula is useless to me. So typically with these sorts of problems, what we're really looking at is making a bridge between a set of facts that we do know, and that is the standardized normal distribution. Okay, so a standardized normal distribution, just to remind you, I'll just do it down here as well. I've done it. The axis first again. Has a mean of 0 and a standard deviation of 1 unit. Okay, so there's a standard deviation of 1 unit. So in other words, 1 unit away from a mean of 0 will be here, and 1 unit away from the mean of 0 will be here, and so on. So the standard deviation, standardized normal distribution, allows us to make some links. And we're told, this is the important part, we're told that 17% are shorter than 168 centimeters. So what we do is we start by saying, first of all, so this is where the that's all the thinking, I suppose. This is the solution, which I'll start on this page, but I'll need to go on to the next page. So the solution, let's write up what we've got so far. We know that x is distributed normally with a mean of 180 and a variance sigma squared that we don't know. We do know this fact, that for z, that's the standardized normal distribution, distributed normally with a mean of 0 and a variance of 1, because 1 squared is 1, at 17%, well, this is standardized, right? So we can just grab that off our calculator. So I'll switch over to my calculator. I've created a calculator with a calculator page added. And I'm going to go to page, probability, distributions, and I'm going to go inverse normal, because with the inverse normal, it asks you for the area. And remember that the probability is the area under the curve, or the area under the curve is the probability. And we're told the probability is 0.17. And this time I'm just going to leave 0 and 1. So I'm looking for what is the Z value at 17%. Click on OK, and I get Z equals negative 0.95415. I'm putting the whole value in. So there you go, you can see I've got it there. Z is equal to negative 0.95415. Now, just to remind you what I've done here then, I've got a standard distribution, and I've knocked off a little bit here, and that's 17% under the curve. And it turns out, using that formula, that this value here will be negative 0.954 to 3 significant figures. Okay, so that's kind of what I've got. And now I need to scale that up to the actual distribution that we've been given. I'll do that on the next page. So the actual distribution we're given is that for a mean of 180, that 17% corresponds to less than 168 centimeters. So if I start with the formula, I have Z is equal to the X score minus the mean all over the standard deviation. Now the Z score we just calculated, it's negative 0.954165. The X score we're given in the question, it's 168. The mean we're given in the question, it's 180. And sigma is a thing that we don't know. Okay, so I'm going to rearrange this a little bit. I'm going to do it by multiplying both sides by sigma. So that means sigma is going to be over here, and divide both sides by 9.954165. So that means it goes down there. So I get sigma is equal to 168 minus 180 all over negative 0.954165. Okay, that's just a numerical calculation which we can perform. So I'm going to get my calculator out and do that. So I'm going to go put it into brackets 168 minus 180, that's the top, divided by negative 0, we have to write negative 0.954165. And I get 12.5764. Okay, 12.5764. So switch back and write that down. So that equals 12.5764. So that is the standard deviation for the data that we actually have. Okay, a bit over 12 and a half. Okay, what are we going to do with that? Well, it's not too bad. We are given in the question that, well, sorry, we're not given the question. I'll just go back to where we're headed now. I'm just going to zoom up on this bit of the map so we can sort of see it. Again, we're given in the question that this bit is 80%, but we don't know what the lower boundary is effectively. Now that we've got the standard deviation, we can work out what all of this is. Okay? If we can work out what all of this is, then this bit is going to be 80, well, all of this minus 80%. So all of this minus that must equal that. Okay? So here we go. The probability that x is less than 192 is going to be what? Well, we'll go back to our calculator again, and this time we'll go menu, probability, distributions, and we'll do another inverse. Sorry, I won't do an inverse, we'll do a regular one. This time we can have an upper bound of 192. U is 180, that's the mean, so we're given that in the question. And sigma is 12.5764 as we worked out. This is why we worked out sigma, so that we can fill this out. And we're told that it's 0.83, right? 0.0001, it's not worth considering, so it's 0.83. So therefore, the probability of x less than 192 minus h must be 0.83. That's just a quick drawing on the side here. So this is what we've just worked out. All of that minus 0.8, which is basically just that bit. So it's this area, all of it, minus the middle bit of the area, leaves us with a little bit of the area. Okay, so that leaves with 0.03, of course. All right, so what we can now do is, now that we've got that fact that that very tiny area here is just 3%, 0.03, we can now use that to work out what 192 minus h is. I'll do that on slide 7. So therefore, 192 minus h is equal to what? Well, again, back to the calculator. Menu, probability, distributions, and this time we're going to do an inverse normal. We use inverse normal when there's a a value that we don't know, but we do know the area. So the area is 0.03, that's the probability. Mu is 180, and sigma is 12.5764. Again, from the question, what we worked out. And that gives us 156.346. So now it's a, oops, I'll put 34H then, 346. So now we can add H to both sides and subtract 156.346 from both sides to get H is equal to, you can use your calculator for it if you want to. Oh, sorry, I had it on the wrong screen. So therefore 192 minus H equals 156.346. And this is a pretty standard basic manipulation. Use your calculator if you need to work out that H is equal to 35.6536. And we need to have it to 3 significant figures. So I'll say i.e. H equals 35.7. And that is the final answer. So just to finish off critically, we start by thinking about what the question means. So we translate directly, this is the bit that they're talking about, into a diagram, a really rough diagram to get a sense of it, feeling what we do know. And then almost always with these kinds of questions, we are then using some sort of standardized normal distribution in order to come up with a value so that we can work out, in this case, the standard deviation. Sometimes you'll be given the standard deviation, you have to work out the mean. But in this case, to work out the standard deviation, and once we've got the standard deviation, we can then use our understanding of the normal distribution in order to calculate what we're looking for. But it's all nice and clear because we started with a diagram which helped us understand what we were looking for in the first place. Hope that helps.